Question 1, exit ticket multiple choice question. An aqueous solution contains 4.0 grams sodium hydroxide in 250 centimeters cubed of solution. Kw is that the pH of solution is 1 mark. So Kw, concentration H plus times by concentration OH minus. We want to find the pH, so we need the concentration H plus signs. Concentration H plus signs is Kw 1.00 times by 10 to the power minus 14 given in the question, and if it isn't given in the question you can assume that, divided by OH minus. Now that is the concentration. Now we need to find out the moles of sodium hydroxide. Now sodium hydroxide, NaOH, so it's monoprotic acid. We don't need to worry about times get by 2 or anything for diprotic acid. Moles is mass over mR, yeah. Sodium hydroxide 23.1 plus 16 plus 1. That's just over the top of my head. It might be wrong. If it is, then my answer is probably going to be wrong, but I'm pretty sure it's 23.1. That's the moles, but we want the concentration. Moles concentration, volume concentration is then going to be my moles divided by the volume. Obviously 1 that in moles per dm minus cubed. So it's going to be 4 divided by 23.1 plus 16 plus 1. I'm just going to leave as its normal form. 40 divided by 401. 40 divided by 401 divided by 250 times by 10 to the power minus 3. Now I've got my concentration OH minus signs, and now I'm going to do 1.00 times 10 to the power minus 14 divided by my answer. Got the H plus sign, but obviously we want the pH, and pH equals minus log 10 concentration H plus. So my pH is going to be minus log 10 of my answer, 13.60, 13.6. These, I'm pretty sure these should be pH over to 2 decimal places, so yeah, that's just not correct. It should be, anyway, I think the answer is C. Question 2. Addition of which one of the following to this much of NaOH will result in the pH being halved? Now, 1.0 m OH will result in it being halved. Now obviously pH, I think we're going to have to think a bit deeply into this. pH is minus log 10 concentration H plus. Kw yeah, that's what we're gonna be using. Kw is H plus, concentration H plus, OH minus. How do you find out concentration H plus? Kw 1.00 times by 10 to the power minus 14, or 10 to the power minus 14 divided by concentration OH minus. Now we've got like now we can clearly see what's going on, which would result in the pH being halved. Well, remember, as H plus ions increase, the pH decreases. So what we want is the concentration of the H plus ions to increase, obviously. So if we add 10 centimeters cubed of water, then the moles of the OH minus ion would increase, and therefore, because we're doing 1.00, let's put in a calculator, 1.00 times by 10 to the power minus 14 divided by 50, 2 times by 10 to the power minus 16. If I divide it by 100, 1 times by 10 to the power minus 16. So the bigger the number here, the smaller the concentration of H plus ions, and therefore the bigger the pH. And we obviously want a smaller pH. We want the pH to be halved. So what we need to do is this OH concentration OH minus needs to be, we can't, because if we add more, then we're doing, it's like doing 8 divided by 5, 1.6, and 8 divided by 8, that's 1. So if we increase the bottom number, the new denominator, this is going to decrease the concentration H plus ion. So it's not going to be that, because that will result in H plus ion being decreased. 100 centimeters cubed of water. No, we're still going to get a bigger number of moles. 5 centimeters cubed of 1.0 meters HCl. Okay, so just HCl. So that is going to be a smaller number of moles. So therefore a bigger number of H plus ions, therefore a smaller pH, therefore the pH will be halved. Because, okay, I think the answer is C. It's definitely between C and D, but I think it's C. Okay, question 3. The equation and rate law for the reaction of substance P with substance Q are given below. 2P plus Q arrow R plus S, and we can clearly see the rate equation K, concentration P squared times by concentration H plus ion squared. Under which one of the following conditions are all at the same temperature would the rate of reaction be the slowest? So now they haven't given us the concentration H plus ions. They've given us a pH, and obviously pH is, well, if we want to find the concentration of H plus ions equals 10 to the power minus pH. So I feel like we're going to have to do that and then substitute it in, and then we can find out where the rate of reactions for each A, B, and C, and D. So in this case, H plus is going to be 10 to the power minus 0, which is 1, it's not 0. So it's going to be 0.1 squared times by 1, which is times 0.01. In this case, it's going to be, well, concentration H plus ions is going to be 1 squared times by concentration H plus ions, which is 10 to the power minus 2, times by 0.01. 3, it's going to be 3 squared times by 10 to the power minus 3. Okay, I get times by 0.009, 9 times by 10 to the power minus 3, and D 10 squared times by 10 to the power minus 4, 0.01. Therefore the answer must be C. And in question 4, the rate equation for the acid catalyzed reaction between iodine and propanol is that's the rate equation. The rate of reaction was measured for a mixture of iodine, propanol, and sulfuric acid at pH 0.70. In the second mixture, the concentration of sulfuric acid was different, but the concentration of iodine and propanol wouldn't change. The new rate of reaction was a quarter of the original rate. What was the pH of the second mixture? Okay, so a lot of, that's a lot of wording for just one marker. Well, obviously we can cross out, and I'm sure you could cross most things out as well. But so it says rate of reaction was measured and at pH of that. So I can obviously find out the concentration of H plus ions here. H plus 10 to the power minus pH. Concentration H plus 10 to the power minus 0.70. But is that going to help us in any way? Let's find out. In the second mixture, concentration for sulfuric acid was different. Okay, that's key. But the concentration of iodine and propanol unchanged. New rate of reaction was a quarter of the original rate. So what it's telling me is that the rate of reaction, a quarter of the original rate, is times by 1/4. So let's say we have 10 times by 1/4, the original rate. That's a new rate. So it's a quarter of the original rate. What was the pH of the second mixture? Well, okay, so if we find out the concentration of H plus ions, 10 to the power minus 0.70, I get H plus equals 0.1995. And that's for reaction 1. Now for reaction 2, if it tells me the rate of reaction was a quarter of the original rate, so okay, so if the rate of reaction was a quarter of the original rate, well then that means that concentration of H plus ions was times by a quarter as well. Because remember, the propanone and the iodine was unchanged, whereas the only thing that was changed is sulfuric acid, which contains the, that's obviously diprotic as well, H2SO4, contains the H plus ions. So what's going to happen is, because the rate of reaction was times by 1/4, the concentration of H plus ions obviously times by 1/4, that's why rate of reaction is times by 1/4. And what will happen to the pH? Well, remember this. Smaller the value of concentration of H plus ion, bigger the value of pH. Smaller the value of pH, bigger the value of concentration of H plus ions. Therefore, pH is not going to be times by 1/4, because that means that the pH would be smaller and therefore concentration of H plus ions would be bigger. But we can clearly tell, because of the rate equation, only this was changed, that the concentration of the H plus ions must be a quarter times smaller, a quarter of the original rate. Therefore, the pH is going to be 4 times bigger. So the answer is going to be 2.80. I feel like, I overcomplicate things a bit, but, there's a lot of wording. If I just, saw through the words, and then I probably could have done it a lot quicker. But hopefully you guys understood that. So now marking it, question 1C, question 2D, okay, so that's wrong. Question 3C, question 4B, that's wrong as well. Okay, that's perfectly fine. So question 2 and question 4 are wrong. So guys, don't copy that. But question 1 and question 3 are completely correct. And I'll go to my teacher tomorrow and ask him about question 2 and 4. Hopefully you guys found it useful for questions 1 and 3.